You know, you can look at the assignment material. Should I ask you anything more about it? How scary is it? I know it's a gigantic piece of material which has been thrown at you now. Yeah, look at the reference manuals.
I think the assignment is pretty scary.
Yeah. Make friends with the reference manuals. You will need them. And if you're not already trained and used to reading reference manuals, we're pushing this now a little bit earlier in the curriculum. People are actually seeing real world reference manuals. In 20,000 people have been trying with the reference manual to some degree. Always giving full answers. Well, how is that combination working out? Because you use the manufacturer's documentation because in your life you will need to be able to do that. And it's a certain skill that needs some training. They're not pedagogically written, obviously. They're very written matter of factly, and sometimes you have to keep them only surrendering what you really need to surrender. So that it's just possible that you program it like that. It will give you even a backup.
Some of the advice is really about manuals mentioned in just you go to talk to actually say how I do this thing and they send you back a script which just writes to it on not to make for a distance. And you say, I don't know what that does.
Yeah, something like that. It's not quite as bad in the assignment, so start to use your assignments. Importantly, is your design division. What part of your microcontroller you will be using in your assignment? Not just the CPU. It's also the CPU and logic errors. There's lots of other stuff there. I don't use timers. I don't use the matrix. Combination of both of them. I use random generator. I use robots. And these are all hardware devices on the chip. Activate them, you enable them, configure them, combine them, see what they do. And then you will take advantage of using that. Maybe easier to do it on CPU or something. And that's all you design for that you need when you go to something. Obviously, it's not a piece of work which most people read cover to cover. Even though I do know people who do read these kind of manuals cover to cover because they're just enjoying it so much. So interesting if you go through that. There's a certain, I'm not saying you have to do that, but there's a certain fascination that comes out of that. You actually understand what are the possibilities which are there. It's just like keeping the toys. You want to know all the toys which are there. All colors, all variations. And some people are enjoying this. Just go through the whole toy store, shelf by shelf. There must be something funny or something over there. Don't do that, time. Try to explore the whole toy store. You have to be more strategic. Okay, the code is actually, do you understand the basic structure of what I gave you? What's happening there? First of all, it's not trivial to even find the control flow in these things. Because what you do is you define a bunch of library level tasks, and they can't be anywhere because they have to find them. I mean, I didn't make it undefined, but just from a general principle, it is often not sufficient in these systems if you just avoid one main program, which is of course classically easy to find. And you can derive everything from that, not the case. You have multiple active entities in there, and I didn't hide them, but you could possibly hide them really. So it's not always obvious to find out what's going on. You have certain advantages given by the Ravenstar profile, because we will be running under the Ravenstar profile. It means that there is no dynamic task creation, and all tasks have to be declared library level. So that limits your search space, where you can find everything that you can. So it's a bit simplified now. So for me, it's not randomly cut down. wondered if you read actually can read some thoughts about it. Next week you will be start playing hardware, which is also a distraction in itself. Getting hardware under control. Not a big deal, but takes a bit of time to get it under control. And you can start coming up with debug strategies. So.
Interrupts. We have seen that. We have seen different ways how an interrupt handler can communicate to your processes. A number of different ways. And the next level is we are cheating, and we have an operating system, which does nothing else but just reading these interrupts, transforming them into signals, which the operating system feeds into the scheduler, and you handle then the signals which are reported to your tasks. Does it sound like heaven? No silly interrupt handlers anymore, no interrupt properties, nothing? Perfect. What's the problem? Yeah. Slow, fast, who cares? Why faster? That's your problem. Any other problem here? Go through the main schedule. So the response times are not only long, but also, by any possible means, unpredictable. The scheduler itself is not even interrupted by that. It's just a flag which is set for the scheduler. And the scheduler gets around to do that next time. It may activate one of the tasks which requested to be informed directly on these signals. It's a pretty indirect operation. Syntactically,
How does that look like? I gave you two angles on that one, the POSIX and the BSD version. Very, very similar, just slightly different names. For brutal battlefield historic reasons, sending out a signal is called kill. Because obviously this was not used for any modification or for any modification. This was used to issue processes. And sending out signals is, for that reason, still called kill today. Setting an interrupt handler, specifying that, looking where the interrupt handler address is, call it a different action or vector, suspending yourself, waiting for signal to arrive. This is again especially a unique command with a predicate. If this signal comes active, then please reschedule immediately. And a bunch of masking operations for these interrupts. Generally, from the perspective of you as real-time guys, this is a bandit. This is a workaround. If you really don't have anything else, you would use that for anything serious in real-time environment. Make sense? Just mention that for completeness. So, now I want to talk about exception handling. And we need to, you're all professionals from the perspective of you have done a lot of exception handling, right? Are you smiling? You have done a lot, right? While first of all, we should just acknowledge that there are cases in philosophy. And that programming languages which
very messy, hard to read, hard to see the control point.
Encourage bad slide or you just catch everything and throw it away.
Mm-hmm. Easy to misuse, often abused. Yeah. But why are these languages not showing the ground? Why are they not designing an exception handling facility which is non-obtrusive? Can you actually afford to get rid of exception handling altogether? Can you live without exception? Not easy. Where's the pain point? Where would you say that I really want
When you want to handle errors that occur anywhere within a basically special function code.
Yeah, exactly. So you have a protocol stack, you have a driver stack of some sort, you call down by 25 levels until you actually get to the piece of hardware down there. You touch a piece of hardware, the piece of hardware goes and you don't have exception handling. What do you do? So if the error code is 25, then I return error code 27. If the error code is 27, then you use that. You make one mistake, and that one is the back. You lose its error. Thus, making your system verbose about that. So it's the opposite. If you have to handle it here, and you do not have exception handling, what you're now saying is that the code becomes even more verbose. Huh. Yeah. So the alternative would be, can you actually design systems which never require exception handling? To be right. Because they have exceptions.
Is it like in Haskell when you propose a bunch of functions that carry out, you don't have to handle it exception?
Well, isn't that exception handling?
I just don't.
Yeah.
So they just return bang, right? Unlike a full stack.
Well, this is just pressing the panic button. What you have in Haskell all the time. It's not really exception handling, it's just give me a breakout. My whole system, shut everything down.
You could spawn a new thread to handle the error and kill the thread that caused the error.
Yeah, it's also a pretty shotgun level method. Exactly. One to get exception handling. Okay. I think from a perspective of high-tech behavioral systems, where we said at the beginning, yes, we want to verify everything, make sure that we don't have obvious mistakes in it, but we also don't want to rely on the fact that, for example, our hardware is 100% reliable. What do you do if you have actual hardware? Yeah, but how do you know that you have
Assume you might have several levels of error. Maybe the first one you try something else over again. If that doesn't work, you try something else.
Yeah.
What if you have some physical
Let's make a new language. And assume our new language needs to have exception handling facilities, because we still think that we need to handle that in some way, not just pressing handling. What would you expect of this exception handling facility? What would be your spec sheet to compile and construct the language design? What's your wish list?
can throw things and catch them?
Can throw things and catch things?
Yeah.
Well, that's pretty much you have exception handling.
How it is that it just depends on the scoping.
It depends on the scoping. Is exception handling depends on the scoping?
Or the level of that.
Okay. So you mean the exception handler
Yeah.
has some relation to the scope?
Yeah.
Okay. Can you give me an example for a programming language where this is the case? Not true for data. Exception handling has nothing to do with the scope. Any language where the exception handler is defined by the scope. more technical, less family level?
Each block that may throw an exception usually has a catch block attached to it. It's not the same block.
No, this is the, what you're talking now is just the block definition. You have a try catch all, or you have a declare exception begin end kind of structure.
Do you mean like the function call somewhere on the stack?
Yes. The exception handler is not necessarily found in the local scope. It doesn't even have to be an exception handler in the local scope in the first place. To find an exception handler, if you actually work the stack, call stack, and you go out dynamically on the call stack from where you have been called from. So you can have, for example, scopes and scopes and scopes and scopes, but if the outside scope calls the inside scope, all the exception handlers in this scope in between are not relevant. Not dependent scope. In most languages, so there are exceptions. In most languages, it is defined by a stack. Give me more. What do you want? Give me more specs. Otherwise, you get a really crappy exception handlers.
You would like to know what kind of exception was thrown?
So you want to have name of the exception or class?
Yeah, I think I figured that.
Yeah. And so the exception itself should carry more information than just simply a name. Okay. Keep going.
Compile to tell me when I'm not handling exceptions.
So when you're not handling exceptions, you want to have a number of things. What are they? So if you're not currently handling exceptions, what do you expect from your language?
Default handler or complaint.
A default handler or complaint? Okay. Complaint. Complaint
Like to the programmer.
to the programmer. That's it. Speed call for satellite somewhat awfully months.
I mean, that compile.
Python.
Wait, so you want to have a full catch block for everything that might not exception?
Not necessarily.
Sorry, I misunderstood you. You're saying you want to have the compiler to tell you off if there is a potential for an uncalled exception. Cool. That's interesting. It means that the compiler will get to tell you off for that, or maybe automatically reps and catch all somewhere. Okay. What else do you want from exception? So in the programming style of, say, interrupt handler, that you want to associate a handler to an exception, like you would associate a handler to an interrupt. Interesting. What would you get? Yeah, you want to be able to re-raise and throw them. Okay. What would you expect the default behavior to be? If you catch an exception, is it automatically propagated further, or is it automatically stopped? Automatically stopped? Automatically propagated? Okay. So you have to explicitly stop it? What's the danger if you have an exception handling facility where the implicit default behavior is, if I catch it, I stop it? What's the danger?
You mean to stop the exceptions of the program.
Stop the exception. So, okay, the point was this is about rethrowing, re-raising exceptions. If you have an exception called in an exception handler, it may be that this exception handler handles part of the problem and then wants to re-raise it to a higher authority, to the next exception handler further outside, common handler. Now the point is, do you want to have an instruction in your language which says re-raise, rethrow? Or do you want to have an instruction in your language that says stop? So what's the default? If you handle an exception, is it automatically continuing if you don't kill it? Or is it automatically stopped? Automatically stopped. You say this because you're used to that. No, because you want
It would be crazy to do it the other way around, because almost all the time when I catch the exception, I want it to stop because I'll handle it, and that would whole program to die.
That's true. It's true.
Like if it was the common case of
more common.
Yeah.
That's a good point. What's the logical danger of doing that? What can happen if you by default stop it?
A high task deadline with no exception was raised. Which was something a lower task deadline.
I mean, you can catch it, like the programmer will know what's the logic and handle such exception.
Assuming you, for example, buy a library from some third-party manufacturer somewhere, and you just slot this in your protocol stack somewhere in the system. And those are a few crazy guys, and not much idea about programming. What they have been doing is stack slicing. But these guys have just been scattering catch-all handlers everywhere in their program. Catch-all, throw it away.
So then what that reaches down to your hardware code, which might
They're already gone because they just have caught all your exceptions. Or maybe you have been late. Maybe you have to let some catch-all handler someplace. And you have not bothered to identify what exception that exactly is because you thought at this point, I don't know.
Can you fix that by just putting a row, an exception in the destructor of the exception, so every time you try and build the exception, it will destroy it again?
Yeah, this is possible if you're living, particularly in Java world, where you can think about something like that. That means that exception handlers are first-class objects that can actually have this kind of interpretation through the exception itself. Often you don't want to go through that heavy machinery to do something like that, but that's a possibility. Right to do that.
Can you fix it by just removing the ability to catch all exceptions in one easy way in your language?
Mm-hmm.
And have to explicitly list them out?
So, exactly, we do want to have a catch-all syntactic construct at all. But we expect that the programmer will always need to enumerate all the exceptions which we want to handle here. Like all. Yeah. What's the danger if you have to enumerate them all individually?
probably just do it and maybe you just say do nothing because that's the easiest.
Yeah. Important question. Can you actually even know syntactically the names of all the exceptions which can rush past your exception?
Yes, in Java, the signature function, for example, will say what kind of exceptions it will throw.
Yes.
And of course, you've got pipe arrays,
Yes.
in some cases.
Yes. And you have to look through the whole stack.
You just look at what all the things you call, and each one will tell you what it will throw.
That
Compiling will automatically work that out for you as well.
True. So in some circumstances you can know that. Besides, you have to solve the word of the holding problem aside because there could be the length function calls and all process as well. But that's the huge function there. So that's an obvious easy way whether we throw away catch-all handlers. What more do you want from exception? Okay, what's the end?
Well, usually you want it to tell you if there was an exception and you forgot to catch it. That you like, not have it decide. But
So you want to have to code anything to have some default safety net when you catch all these exceptions which bypass you somehow. What do you want to happen?
they'll probably tell the program and tell you, maybe, or even better, just call some predefined handling method.
Okay. Is that the same as just outside emergency handler?
Well, it's not necessarily, because like usually the catalog you put it in a block of code that is executed, but you might be throwing in some other code that's not. Like it might even be thrown for your main procedure access, for example.
If you think now you're thinking about handling exceptions, but you raised it a very important point at the beginning, namely exception handling can be obtrusive. What do you want to happen, and your programs look like, if that willing to write off for the facility that you have exception handling in your program. You don't need much performance.
And it's really any, just something.
Nothing.
Pretty much nothing.
Possible, but if the alternative is to have a minor error and it breaks everything, then even if you have to compromise, even if you throw away a lot of performance to catch that, that's still better than you open the file that isn't there and the computer crashes.
Okay. So are we willing to sacrifice a little bit of performance for exception handling?
Well, if you're going to throw exceptions, you're obviously going to have to pay some kind of cost to do so. If you're not throwing them, there's no need to actually pay any cost.
Okay, but that's an important information for the language design.
Yeah, you implement it intelligently, and you'll have no problem. If you implement the exception handling dumbly, then sure.
Yeah, you have no imagination of language design. But of course, we would want to have a situation where there's no exception, there's absolutely no noticeable performance difference, no runtime behavior change of your code. Is that possible?
Yes, that's right.
Okay. Wouldn't you, for example, think that if you have tons of exceptions and exception handlers defined in your code, that your code size isn't that possible? So if your code size increases, wouldn't that have an effect on the performance of the machine?
It only increases if you throw in hash.
No, the binary code has your exception handlers in them.
If you have no exception handlers, then it's all good. It's not
No, we're discussing whether there will be performance.
Oh, you have handlers but no exception to actually throw.
Yes.
Oh, that's what you're talking about. Yes, okay, we'll increase by only slightly.
So if we can compromise to...
So about the price increases you'd expect when you write extra code in your file.
But it doesn't really affect much performance. It's just a lot of binary code sitting there doing nothing. It's just taking up space, but it doesn't really. Okay, the space complexity will increase much of the time.
Yeah. Well, you just have to see the full picture. So if your binary code is actually increasing, which means that it will have an effect on your caching performance.
We will catch those handlers.
When we mark these handlers as being caching.
No, it is catching. It's just catching the sort of the most recent machine.
No, we'll also preset instructions that may be called, like if it's nearby any file, it will likely be cached.
Okay, so maybe we specify for the compiler constructors all codes which are related to exception handlers, please put them somewhere separately. So keep the actual core programs, the sequential part of your programs, as compact as possible in one binary box somewhere, and explicitly separate out those codes somewhere. Don't have it by itself, just specify.
Like if an exception is actually put that also takes it out.
Yeah, but then it's probably not count.
Yeah. Okay.
And it's not the balance. Do you want to have your exception handling as fast as possible, or do you want to have your main program as fast as possible? Mostly the main program, because in case you have an exception handling in the real-time environment, you raise an exception of some sort, you know that you are already in some kind of trouble anyway in terms of your timing. So that's by default already a critical situation that you most of the time have to raise in terms of the real-time behavior, some emergency behavior anyway. Maybe that may not so bad. In terms of syntax, in terms of readability, you want to have it non-obtrusive. How would that look like in your mind? A non-obtrusive exception handler, which you just look at your programs, you can see. Very good. How do you express it?
Well, without the required curly braces, it's fine.
So you say 2 characters.
Yeah.
Okay. Let me give you a few things which we could wish for. Those are the common things which obscure the understanding of normal exception protocol. We set that. The exception handling facility should produce no minimum runtime overhead until an exception actually occurs. We set that. Exceptions should produce predictable runtime overhead when an exception occurs. It becomes a little more tricky because we're still living in a real-time world. So even the exception handling facility has to be predictable in itself. So that the exception handling facility is supposed to trigger some garbage collection load from a file somewhere. It should also still be predictable. Exceptions indicated by the runtime environment and by the program itself should be treated uniformly. You agree? You disagree? What are the differences between exceptions raised by the runtime environment and by you? Is there any difference?
Occasionally, you might not be able to suppress a runtime exception because if you can't do it, like if you run that over, runtime in general.
Have you ever seen a runtime exception? In this course? Good. You're such a genius in a program? You've never seen a runtime exception? Range constraint violation? Well, that's a runtime exception. They have a very complex runtime system there. It's very different from Java or from C where there's a runtime environment. So if you do have a language with strong runtime environment, you have a whole bunch of runtime exceptions which are terminated. Where all the exceptions which you have seen so far in your programming created by you. Most of the things which you have seen created by runtime exceptions. But syntactically, would you treat them same? Treat them different? Same. Okay. Exception mechanism should be applicable to asynchronous and synchronous exceptions. What are asynchronous exceptions?
You might throw it to another currently running task or something.
That's different. That's a different concept again. What is asynchronous? But it's related to that. A bit more general, what's asynchronous exception? Your normal, small step back. Your normal exceptions, which you have handled in all of your programming languages so far, is that synchronous? Is that a synchronous operation? Yes. 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 You agree? Okay. So exception handling, as you know it, is a completely synchronous operation. Synchronized to whom? When is your exception raised? In your own code? Yes. But it's raised in your own code when? When something breaks, and you run over a piece of code. You call it object function, call it object conversion. Yeah.
So what about like an entry call on the task?
Entry call in the task. What kind of exception do you expect there?
I'm not sure maybe something goes wrong inside naturally rather than
If the task is throwing it. Yeah, I've done that before. Just a small task.
So if you go for calling an entry, and for example, the other task doesn't exist, you get a tasking error exception, then you try to call a task which there's nothing there, grab anything there. It's still synchronous because it happens exactly when you call this task. Okay? So yes, all the exceptions that we have seen so far are actually synchronous exceptions. Give me an example for an asynchronous exception. Is that something? That I'm running a Python program. How is that asynchronous?
Because pull that thing outside of the thing you can actually run it. Like essentially different thread.
But how do you get this exception from your Python program in your real program? But how is that asynchronous? Or asynchronous to what?
You can get it anywhere. You get an unrelated exception.
An unrelated exception. Okay. An give me a more practical real-time example than your Python program.
Maybe a hardware device randomly sends bad data to the processor and just throws exception manually.
Is that again more an interrupt?
Yes, it's an interrupt, but it's an error interrupt.
An error interrupt.
So that can be called by a capture or by whatever they happen to be writing at the time.
Well, to put it the other way around, is there actually a semantic difference between an asynchronous exception and an interrupt?
One comparable reason.
I mean, parallelism.
One can
Yeah. Okay. Yeah. Okay. So there's a semantic difference.
it's also with exception things like throw off. Throw off the stack frame, but the interrupt just goes to specific handling.
Okay. So the handling of an asynchronous exception could be, for example, handled by a propagated exception handler. You don't know where the exception handler is. One interrupt handler usually has these letters. Okay. An exception mechanism should allow for appropriate recoveries. In other words, once your exception has been handled, now what? What do you do at the moment if an exception has been handled? What happens in your classic program? It keeps on going where?
Where you handle it.
Where you handle it. Okay. So at the moment, you call your whole protocol stack, device stack, you propagate your exception handler to all the way up here, and this is the exception handler. It's being executed, and then the code which follows in the block after this exception handler is executed next.
I mean, there are resumable exceptions.
There are resumable exceptions, are there? Which programming language gives you a resumable exception?
Why would this also?
This? Yeah. Okay. What is the concept of a resumable exception?
You might get an entry back into where you were, which is in relation to the just go back and keep going until you fix the problem.
Yeah. So, for example, you have a numerical problem somewhere, something ran over. You fix it, magic, somehow. And so say, okay, keep going again. This was just a little interruption in the middle of it, and I just fixed it, keep going.
Is that the same as putting a try catch around every spec that you can? Yeah.
Once you know back into where you were, you have a
It's more fine-grained than the language level statement level. Because you can have an exception, for example, if you have a statement which is a long arithmetic expression. And somewhere in the course of this long arithmetic exception, well, there's the exception being raised. Now, if you have to catch all or some raise, try, whatever around that one, this expression is abandoned. And you continue with the next expression. The resume handler would allow you to say, I have a handler here, and I got so far in my expression that exploded. So treat it a little bit, somewhere, and then continue your expression. That would be a true resume exception handler. And you can have this in some environments. Is that a classical or useful pattern for real-time programming?
Because you don't want to have to restart it, you just did, it's just going to take time. You do a minor fix.
Is it possible that stuff which happened before changed, but not continuing on? Since you paused and you went back to it, usually the rest of the stuff is the same.
Yeah. Okay. There's a third possibility. So we are a little unsure about resume at the moment, but this is a cool idea. We have the semantic, which are all three with reporting whatever is going on, continuing with something else, of course. What's the third possibility?
Just ignore the exception that no one was expecting it.
Yeah, give me that. What's the next possibility? You actually indicated it somehow. As I said, if I work my exception and my expression to that level, I can abort the whole expression and continue with the next line of instructions. That's the normal one which I have called programming languages. If I have a resume model, where I have a function programming language, I have this frequently, that in the middle of this expression, I can continue working. The third possibility is
you just jump somewhere else.
That's equivalent to continue and do something else. The third possibility is I'm not letting this go. I'm trying to execute my expression here, and it failed on me. Let's restart it. So go to the beginning of that thing, and let's run that block automatically again. And you run this block over and over again until it finally goes through.
You just put a triangle in the wall.
Something like that.
Yeah.
Well, but that alone doesn't really work because you also have propagated exceptions, so you don't quite know which block that is exactly. That doesn't really work easily with that. But that's a concept which, when would you think about a concept like this?
You want to set up some critical packages for following and you just keep trying this over time.
This comes from the philosophy of programming by contracts. If your specific function has a contract attached to it, this is my precondition, this is my post condition. So anything happens in there, you're not dropping the post condition. So I'm not getting out of this until my post condition is fulfilled. Damn it, could you now try again? From a real-time system perspective, it's a bit dodgy because maybe it's not possible because these are not going down. So I just can't do this as often as I want. I'm not getting this done. It just means we're just infinitely repeating the same thing.
Is there a way to have a limit on that? Like how many times you can actually retry?
Yeah, combine that with other methods.
Yeah, like resume for a while, then give up.
And you can, as you already suggested, putting some other control structures around it, you can emulate most of these things somehow. The one thing you cannot emulate is an actual true resume function. So from the, if your programming language doesn't provide that, you cannot program.
Depends on what your restrictions on the handler are. You could have the handler be a new thread, for example, that you can just resume.
No, because the control flow is lost. You don't know
No,
where
you spawn the other thread. Your main thread was better, like a coroutine. You swap the other coroutine. When it finishes the work, you swap back.
Yes, but your programming language needs to be prepared for it. So if I give you that, for example, in Java or in Ada or any language which has the exception facilities you're used to, you cannot program.
You can't start a new thread and pause the old one and then resume the old thread.
The program counter in these programming languages, when the exception occurs, is gone.
Yes, no, it's still within the thread. You can still emulate it, can't you, by just literally telling the thread to pause itself until someone explicitly breaks it up. And then the program can stay. And then when you want to resume, you explicitly wake up the thread that just created.
But this has nothing to do with the exact languages that you have in languages.
No, it's like using it. It's basically doing the same thing.
Yeah.
You have an exception handler that allows resuming if everything else in your program has to be done on every action defined has to be the smallest atomic, most indivisible portion you can get. And then if you get to the adding these two numbers divided by 0, it's very clear it just breaks into your normal exception handler. Or is resuming more fundamental than that?
Most programming languages actually fall into one of these extremes. So either they try resume no matter what, or they try jumping at no matter what. Very few programming languages, but they do exist. If you actually choose. So this exception has to be handled in a specific way. Well, if there's only big parameters at that one, if I want to try to resume 3 times, then terminate.
I think it's hard from a library perspective to give choice. So you don't have one system where you include a library, you might have to try and resume that library's exceptions and it's resumed for once.
Code combinations is always a tricky one. Because we already built, besides the actual syntactical language features, we also built at the moment some kind of philosophy how we use them. And this philosophy may not be appreciated by the other game, which writes the other part of the system. How do you combine them?
Do you find that there's like some really funny stuff, like when we divide one number by 0, you couldn't tell it as a natural thing, or just give you a down number and the code just counts?
Many languages do that, not only Python. The idea behind that one is, exception keep pushing, keep going. But that's the classical Python approach to it. So no matter what, keep that thing going, keep it going, even if it's only bashing all the number values around after some time, it still runs somehow.
What's the point of doing that? Isn't the rest of the code just like invalid now since you got one for the rest will just sort of propagate down until you finish?
Depends very much on your programming philosophy. If you come from a world, for example, of pure strict functional programming, this is more the norm than exception handling. Because then you can assume that for every value you have, you can associate a maybe type with that, you can associate an extra value with that. And this extra value is implicitly your exception value. And you propagate this, but just keep calculating. And if you want to, you can have a pretty funny looking exception handling, but just having, if the input value is actually not a number, do something else. So that's even worse. We talked about this in a moment. But it's a common philosophy to avoid exception rating and just associate a funny value and just keep going. And of course, this is the opposite of real-time and high-technical programming. This is the end of just make the user happy, keep it going somehow. As long as it runs, the user is happy, just do something, keep it going. Python was the perfect example. As I said, many functional programming make it do the same. All right. So I want to go through a number of ways of doing exception handling. Yes, I have to look at that. Because you will have seen that plenty in your life, right? This is not exception handling. This is the classical C library interface way of indicating errors. And I guess this is the reason why even the most hardcore C programming fans will be whining. Because number one complaint from industry, from places where C is used for some level of programming, the number one complaint universally is type 1 exception. That is absolutely terrible. If you write large programs this way, this kind of programming is so error prone. And it's of course cumbersome. It makes your programs extremely hard to read. What are the other dangers in terms of practice?
Forget to check for an error. And then one day during completely mistake.
There's no synchronization here at all. Yeah. The error number is classically defined as a global variable, globally in your system. So you call something, and then you look at a global variable. This is the same global variable the other 500 processes look at as well. Now, it's not as bad as that. People notice that this is a problem. And in most current Unix, Linux, POSIX implementations, this has been solved behind the scenes. But please check that before you do anything like that. If your error number is not thread safe, whatever that means in that context here, you are of course doomed from the start. You're definitely meeting wrong error numbers if this is done in the current environment. And really hard to find where is the normal control flow in these kind of things. Because the emphasis is all on the error handling. And you have to do this error handling everywhere. You cannot just skip it over a few levels and then do it at another point. This is probably the one most painful point of C programming today that we don't have any exception.
Is that logically different from another nicer exception handling framework? Because it does seem like a lot of it's just sort of the layout doesn't look very nice, it's easy to get payments and all that sort of stuff. So couldn't that be fixed by some nice libraries and function calls?
Not really, because there's no way how you can catch an exception, write an exception handler, 10 levels up.
And you just keep returning error values. Yeah, I think people do that as a macro. They just wrap it in a macro, and they would return an error, just return an error.
Okay, that's the C answer to everything. You just macro everything. You have done that? You have any macro programmers? Okay. I would invite you to try that. Play with that one. Let's say besides some languages which made a different philosophy out of that one, I strongly hope that macro programming is a piece out of the past. Besides your working assembly programming, classical macro center for that purpose. Higher level programming language, macro programming, just in order the downfalls of doing macro programming, or the problems of macro programming. Yeah, what is that yet? Why is macro programming so hard?
Usually only a static thing, sort of like type say or dependency. You can share a variable. It doesn't like doing syntax change or you like to use it.
It is nothing but textual find and replace in your text edit. There are a few parameters around it. So it's a nicely formulated graph search with a nice replacement form on character level. There's no understanding whatsoever what your program structure is, what your types are. So it can screw up really bad. You have no visibility. And you don't even see where the error is because most of the macro processes which we use are not showing you the code which is produced afterwards because processing it through and then some really funny stuff happens. Okay, so actually I'm not sure this would be the answer to these kind. Okay, so I think that form of exception handling is probably absolutely medieval. How do you do exception handling in assembly? Go to, yeah, but go. When do you actually call this go to? How do you use that in a structured way?
Basically, do the exact same thing you can see. Branch is the value of register, is error value, then branch to error handling code. Yeah, or you could manually just create like you could just manually implement the step look up the branch until you find something that looks like the platform you know that. Basically, how you use it.
Think outside the box of C programming. Look, you can't emulate a C programming way of doing that. Using a trap environment, going, yeah.
You could put your cache block in the register, and when you turn it, you just jump to that register's value.
So have the target address in the register and then jump to that. Okay. Here's the classical way how you see this in assembly programming most of the time. You jump to some subroutine. And on return of the subroutine, after the subroutine, you enumerate the exception handlers by explicit jumps in your code. How do you raise an exception now? You manipulate the return value. So you have the return address on your stack, or wherever you handle your return values in your architecture. And you manipulate, you just give it an offset, which triggers that on return of this function, you're not returning to the next address directly, you're returning to the exception handler to be applied there. Downside is, if you don't have an exception, you also have to deal with that, because then you have to manipulate the stack pointer so that you jump to all of these exception handlers and actually continue with the code. That's a very compressed, easy form of doing this in assembly level. For completeness sake, in historical levels, you do have actually jumps, go-tos for that one, so you hand over jump labels to your subroutine. If it goes wrong, just jump there, like exception handler. So that's one possibility. Or a little bit nicer, procedure variables. Just hand over a bunch of procedure function pointers to your exception handlers. Just want to show you a little bit of the historical torture chamber around exception handling, how this has been done in the past and still being done in live C programming today. By the way, language experts, computer science experts, what is the first programming language which offered exceptions? The first programming language? No, that's exceptions. Yeah. C++. You assume what?
I assume it's not right here.
You assume it's older than C++. Okay, let's go historically. Lisp. Not effective. So, yeah, not really. Sometime in the 70s. You're wrong.
No, I mean in terms of a list that has exceptions.
Yeah. Okay. Fortran? Nobody knows what. Cool. Aldo? PL1? Basically, it's quite a young programming language. PL1. So we're talking 60s here. What's PL1? This is from the early 60s. Well, PL1. I think the imagination of people making programming languages back then was not that expensive, so they called this PL. You can guess what PL is. And you could do something like that, which was a little clunky, but I think that was the very first form of exception handling to be qualifying as such. I find it funny because that's 60s, early 60s, and C has been invented for after.
It would have been slow on machines in the 70s. Yeah,
That's way down the road. It's actually quite cleverly implemented. No performance impact at all. But this goes for a lot of C designs at the time. That's the reason why when the computer science community very much as a whole was just going Jesus Christ. Because we had algorithm, we had tons of other programming, see through it all the way, and started from scratch again from some macro level, macro assembly level programming stuff. It's quite historically quite interesting. Okay. So, categorizing syntactical structures for exception handling facilities. I categorized here by runtime environment and your own programs, and raised synchronously or raised asynchronously. In the context of your ADA environments, you have everything which is synchronous, regardless where it comes from, is an exception, handled by your exception handlers. Asynchronous stuff which comes from the outside, from devices, or your runtime environment, raises an action interrupt, and 10 by an interrupt handler. And everything which is raised asynchronously from within your processes, from within your tasking system, is a different concept. It's asynchronous transfer of control within your tasks, not interrupt. That's a different form of control. Okay, can like it or not, but those are three different forms to handle of the four possible different forms of exceptions. Real-time Java, everything is an exception. Java, everything is defined as an exception. And asynchronous exceptions are just a special form of that. We have to look a bit more careful how you handle it, how this expresses itself in how you can do that. So it's an interesting concept, and there are pros and cons to that. Doing it all by the same syntactical structure is problematic in other ways. Just for completeness sake, just if you program on a library level in there is nothing on any level. You don't have any direct support for interrupt handlers, exceptions of any sort. You have signals. If you call global variables as some form of communicating exceptions, then you have global variables to do that. So, on what level do you want to handle your exceptions? What is the healthy granularity of exceptions? That's a common way you're used to that kind of environment. You're defining exceptions based on a block level. Can you define exceptions in another level of granularity? It's very universal, but if I want to do this, for example, for individual statements, my code will go up. If I want to have exception handlers per statement, that would be syntactically easily defined. If I want to have exception handlers which are spanning more than one block, how do you express that? A bigger block. We need a bigger boat. Okay? Okay. You of course have in both possibilities, in both of these languages, possibilities to catch all. And we discussed a little bit whether you really want to have a catch all or whether it is potentially dangerous in some environments. Exception handler which is barely noticeable. You have one tiny exception handler after a long code block. Nice, very readable. Bad, very unspecific. You don't really know where this happened anymore. But maybe you do. Couldn't you find out where this happens? What do you need to be able to find out where this happens? That thing? Yes. Let me say, for example, the runtime environment doesn't give you that option. If you have a lot of numerical expressions here and you have 20 possibilities for, say, division by zero or range check, whatever, you don't have this option. And you still find out where your division by zero actually happened.
Yeah, you could just put a global variable and after everything you do, the might put division by zero check, you just increment it and then different way. Yeah.
I think that sounds a little pedestrian, but yes.
Well, maybe not. It doesn't have to be easy. You can have it like a label, like an enum.
Yes. Wouldn't that be something you can install? If your compiler is friendly enough. The exception occurred. At this point, when the exception actually occurred, the compiler is still, or your runtime environment is still full knowledge. It knows exactly where it's happened. And before the exception is raised through your actual exception handler, what stops you, or what stops your runtime environment, from just attributing the the exception with where's the PC in the moment? How does this translate maybe to my code actually? That's also exactly all.
You just load it. Well, PC, there's probably not enough information there because you could call the same function 10 times. So, so you might probably want to know the entire backtrace.
Maybe sort of not to.
Okay. In your exceptions which you handled so far, in your ADA exceptions, what information did you get with your ADA exceptions? You've got the exact line in your program where it happened. Right? Who do you think did that? Of course, the runtime environment attributes all exceptions automatically for you where this actually happens. Now you can actually find out where this happens. And that gives you a bit more possibilities to do that. But you need to have this part of your language that is automatically telling you for you. You cannot do this in post. Besides, you have to increment after each individual line of your code, individual statements, count is made.
Right, practically that's nice for the programmer. You know, if they're sitting there watching a program, they're out, they could be fine. But if it's running, you're doing the things that you want to automatically do.
You could just use macros perhaps for the numbering.
Come back to macros again. Well, of course, we scatter the exception handler, but I mean that's obviously quickly getting very complicated. Let me pull out another language which you're not familiar with, where exception handlers are associated with individual statements. And you can just enumerate for all different possibilities which can go back with this specific statement. You can attach exception handlers to that. There's no propagation happening. You need to syntactically attach them right at those spots. Pretty harsh, pretty brutal. Very easy to verify. What's your angle on, hang on, we discussed all the different possibilities of your super wish list for the best exception handler on the planet. Did we discuss whether you want to have propagation or not? What is the outcome?
We want propagation, I think.
You want it?
Well, only if you want to propagate. And then if you manually
You want propagation if you want propagation, I understand that.
Yeah.
About that, since all exceptions need to be handled, how did we don't know they will break the exception?
With the project compiler intel. It's pretty harsh. The compiler will actually tell you off. Whenever you do this, those 500 exceptions can happen. Now what? There's no uncalled exception because your compiler is so there's no exception. But your code is not very easy. So we want to have exception propagation. You want that exception propagation. Where do you want to have it propagation? Yeah, but which handler? You have 20 handlers defined in your system everywhere. How do you find that? Call stack. That's a classical one. That's what you want. You want to have a call stack. Not the scope link. You want to have a call stack. Not propagating the outside scope. Not propagating the outside call. The trouble is, if you work like that, if you propagate along the call stack, you cannot know who called you. So depending on who called you, there are a whole bunch of different exception handlers which can be raised in those situations. You don't have a hard association between an exception and an exception handler. The issue, you want to have a hard correlation that this exception is always handled by this exception. can think of an interrupt handling facility where interrupt is handled depending where you are in the program at the moment by a different interrupt handler. Is that be okay? Yeah, it is. Would you like that? Okay. Quite so obvious which is the same operator model or flexible or iterative one. Okay. This is about exception attributes. Two very different philosophies, which I wanted to throw in you. The Java philosophy is it's in your hands. Exceptions are objects like everything else. And you can define what you want in these exception definitions. Cool. It's in your control. And this can be a whole jungle of exception. Okay. But there's no information behind it. Your runtime environment doesn't have anything. On the other side, exceptions are quite minimalistically implemented. They are not, you cannot inherit from an exception. Flat namespace. There's no, I derive something from an exception and extend it somehow. Means that the implementation of that is automatically more efficient, but the flexibility is not less. On the other hand, you do have the runtime environment, which automatically attributes some of the important stuff for you. For example, where was the program number, was the state of the whole thing. So you can have information where it's happened. And there's a bit of a compromise, you can add streams to that. Not particularly excessive. Okay. Where do you have to declare the exception scope? How do you know what exceptions can be raised if you use this part of the program? How do you find that out? That's what I mean. For the catch-all, yes, you don't care about the name of the exception. But if you do care about the name of the exception, where do you look syntactically to find out what the names of your exceptions? That's a lot really. So you can read your whole code and collect all the race magnets in your code anywhere. Not really, because the compiler doesn't know what to call.
But the source code for the program you're writing knows what it's calling and knows what all of those things are. And you go see all the exceptions that you're writing.
I don't know what they're calling. You can, of course, look what is in the scope, possibly, or syntactically, but even that is dodgy because if you have, as you said, function pointers or any other relation that even that is blocked. It's not that trivial to find out what exceptions can be. Very quickly you find yourself A, what is the syntactical scope where my exceptions are declared? What's the syntactical scope where exceptions are declared in M? Package level. It is really coarse, right? It's package level, right? So then the thing, and then you have at the end of the package, oh, by the way, somebody in this package, I don't know, works anywhere in this package, those 5 exceptions can be raised. Great. You have to handle all of them, and I call it just any of those functions. And you also have to consider the possibility that you may have an exception handler, which is so far outside the scope where this actually happens, that you name of this exception. This is particularly problematic. So what will happen if you have an uncalled exception? Are we talking real world stuff? There? That sounds like a great plan.
Should program reboot. Yeah, well, that's how you pick my problem.
If you're an embedded system, you might tell someone else. There must be some supervisor here. Okay, you have your physical device at your hands. You are, I don't know, satellite. And you have an uncalled exception. It happens.
Shouldn't be a really bad program to actually let that happen though. Shouldn't we catch it?
So you say that property philosophy, and the place where I will be working is there will always need to be a catch-all handler at the outside source.
Oh, yeah, you can't really uncall exceptions because there's nothing reasonable to actually do unless the program says what it should do. So it's up to should be up to the programmer what to do, not a general thing.
Yes. So what measures do you put in place to run or educate the programmers that they find and know and handle all exceptions? So how do you go about this?
The compiler requires everything that might throw an exception must have a catch like Java does, something like that.
Yeah, but is it caught in the right scopes? Function pointers. I can't get this out of scope. This cannot, it's not easily checked syntactically. So we're going to chill. There's an exception handler for every statement and for all possible exceptions. Guys, end of story. No propagation. Propagation is a dangerous thing in that context.
You could mark on the signature or type of your function point what exceptions might throw.
Yeah. And then?
And then you have to catch it.
Yeah.
Someone has to catch it. You could email someone like the programmer.
Yeah. And the problem is, of course, if you have an uncalled exception and you are in Mars orbit somewhere, the phone call may be expensive. And
They specify they had an error on this program running that. So they fired up a record and patched it while there's hundreds of thousands of pointers.
you must be a little lucky that you have that communication chain. So what is usually done is exactly what you said. And with that, you do verify your system to the degree that all possible exceptions and all possible propagation traces in the system will lead to an exception handler to define exception handler. And they're all enumerated. So this is a question simply of program verification. Simple. You can allow that, and this is done behind vector systems. You can actually do that on verification.
Well, it's easy to do. You've got like single thread program, you just make sure the name and the catch. You've got multiple threaded. You could every time you create a new thread, you could assign a catch one. Then it's easy to do.
Not quite that.
You only need to register a global handler.
You always can, of course, register a global handler and have a catch all handler. But what are the catch all handlers doing for the global scope in those high integrity systems? What do you expect them?
Restore to a system that will state that these names you work with, or take you to you got something completely unexpected. You weren't
Yes.
expecting this to happen.
Obviously, you got something unexpected, but something exceptional, exactly. But what is the form of this exception? It's obviously not an exception which you anticipate. Because if you anticipate this exception, so in all foreseen circumstances, in all foreseen exceptions, you provide an exception handler. That gives you automatically a conclusion that if you have an uncalled exception on the outer level, that must have been something which your design does not include, unforeseen. What could that possibly be?
You could have implemented your design incorrectly, so it sounds like it's likely to be
Assume for a moment that your verification was okay. Assume for a moment that your assumptions have been violated. So you verify a system based on the assumption, for example, that I do have a computer. That's roughly what I mentioned it to do. And one of these assumptions must have been gone wrong. That, for example, your CPU runs backwards all of a sudden. And you run into an exception which has not been possible in logical sense. Can only be explained if your hardware went haywire. So the usual conclusion, if you do that, you have an uncalled exception on the top level, shut that thing down. It's dead. It's dead.
It's not all of the statement, like we have within our routine, although we don't really know in which step we are watching. So like the catch-all, and we'll just
It's harsher than that because you're actually powering things down physically. And you're probably all aware where this goes. Sounds all like a great plan. You verify everything, and then you lose how to build nodes. Like happened in the Ariane 5 crash. It was an uncalled exception. An uncalled exception is a system which has been fully verified all the way through, and it still has an uncalled exception. And this uncalled exception, as it was actually logical fault in the system, happened on all computers at the same time. We have uncalled exceptions, all lines, all computers shut down. It was not really helping for the rocket boosting into space. And immediately exploded because it was completely controlled. Okay. You know how this happened? You know how this error came into play? The short story is that there's a whole succession of this code, and program verification happens slowly, step by step. There's Ariane 3, there's Ariane 4, there's Ariane 5. All has been verified and left in there. And the development of these control codes, which are all fully verified, usually is a bit incremental and evolutionary. And there's an unfortunate tendency, which we now know is really, really bad, to leave all code just hanging. Leave all code there. Because who cares? It's fully verified code. And there was one thing that overlooked, namely that this fully verified code was fully verified under the assumption that you are flying Ariane 4. And it would never have raised an error if it would have flown on board an Ariane 4. The same code, which was not connected to the engine, which was not controlling anything, it was just code which was running there somewhere. This code was flying as piggyback, as a little add-on on Ariane 5. The Ariane 5 controller, also fully verified, was happily flying its Ariane 5 controllers interfaces and its rocket boosters, and not raising any error. But the Ariane 4, after a few minutes into the flight, went, it's a bit fast. That's a bit fast. That's outside my space. This something went really wrong. I think I just exploded. This is no good. I'm way too fast. And raised an exception because after all the clean verification, this could only possibly have physically happened if I'm already about to explode or have exploded. I could never have been that fast. So the Ariane 4 controller pressed all the stops and said that something is really wrong. This is absolute haywire. So the Ariane 4 controller, which was not in control, panicked, pressed the emergency stop button, raised the inception, which was raised on all computing lines at the same time. Or the Ariane 5 controller went with the heck. But the outside patch all handler, which concluded that this can only happen if I'm just about to explode or my hardware is in flames, better shut it down. Funny combination of miscommunication, leaving stuff in the wrong places, and even so, we have fully verified code. A few assumptions which are just also lessons learned from that, obviously. There's a bit of financial loss associated with that. But still, there's very little you can do to have this 100% safe. The default behavior in all of the real-time systems is though you do not have a default any button, you have to program it always manually. It's not a one language for you. The task does not come with an exception handler automatically, even though we have this routine of doing that. And whenever I define a new task, the first thing I do is define an exception handler for it. Even if it's only a catch-all exception handler for my debugging purposes, I always
How would it be nice to be able to look at unhandled exceptions? So you wouldn't catch all the nice stuff that way.
Yes, if you want to go to a debugging environment, then you can do without it, but nobody's also going to catch all the rearrange and do some other environment. In tasking environments, I'm not sure whether you really deal with this here. You see the exception raised from the main program. You see the exception from your task. Not in the class, but you
There's no way to make it so that if your task dies, it will print a message or something. You have to manually.
well, it's what you do then. You're the big macro and manual program expert, so you put a print statement at the end of all of it.
You can't just make it do that for you.
Right. Thanks a lot, guys. We saw aspects of exception handling from all different angles and possibilities, and we clean it up next week with the